There are seas, mountains, dunes, though not of sand, but of refractory organic substances. And when summer comes at the North Pole, it even rains from methane. It is, in fact, an amazing world. Yes. It's about Titan. The largest moon is Saturn, the second largest satellite in the solar system, after Jupiter's moon Ganymede. It is the only, besides the Earth and Mars, a body in the solar system on which the existence of liquid on the surface has been proven, and the only satellite of the planet with a dense atmosphere. Titan's diameter is 3,200 miles, which is 50% larger than that of the Moon. At the same time, Titan is 80% larger than the Earth satellite in mass. Titan is also larger than the planet Mercury, although it is inferior in mass. The force of gravity on it is approximately 1 Earth family. Titan's mass is 95% of the mass of all Saturn's moons. Titanium's atmosphere is predominantly nitrogen. There are also small amounts of methane and ethane, which form clouds that are the source of liquid and possibly solid precipitation. There are methane-ethane lakes and rivers on the surface. The pressure at the surface is approximately 1.5 times higher than the pressure of the Earth's atmosphere. Surface temperatures range from -274 to -292 degrees Fahrenheit. In fact, Titan is fraught with many secrets, but today we will turn our attention to its amazing landscape. So the surface of titanium is mainly composed of water ice and sedimentary organic matter. The geologically young surface is mostly flat with the exception of a few rock formations and craters and a few cryovolcanoes. The dense atmosphere surrounding Titan did not allow the Moon's surface to be seen for another time, until the arrival of Cassini-Huygens in 2004. Despite the low temperature, Titan is juxtaposed to Earth in its early stages of development. And it cannot be ruled out that the simplest forms of life may exist on the satellite. In particular, in subsurface water bodies, where conditions can be much more comfortable than on the surface. Here we see how the titanium surface in different spectral ranges at low latitudes is divided into several light and dark areas with clear boundaries. Near the equator, in the leading hemisphere, there is a bright region the size of Australia. It is a hill, probably a mountain range. It was named Xanadu. Radar images show mountain ranges over 1,000 yards high, valleys, riverbeds flowing downhill, and dark spots, filled or dried up lakes. Strong erosion of mountain peaks is noticeable. Streams of liquid methane during seasonal rainstorms could form caves in mountain slopes. It would be an incredible experience to explore such a cave. To the southeast of Xanadu is the mysterious Hotearcus Formation, which is a bright arc. Whether this structure is a hot volcanic region or a deposition of some substance, such as carbon dioxide ice, is not yet clear. In the equatorial bright region of Aduri, extended chains of mountains or hills up to several hundred yards have been discovered. These mountains are very steep and it will not be easy to climb them. It is better not to do this. Supposedly in the southern hemisphere, there may be a massive mountain range about 93 miles long and up to a mile high. The tops of the mountains contain light-colored sediments, possibly deposits of methane and other organic materials. All this testifies to the tectonic processes that form the surface of Titan. We propose to go down a little lower to the landing site of the Huygens probe. You can see stones of a rounded shape that could have formed when exposed to liquid. Methane gives the air an orange color. They should not breathe because over time we will become the same color, and yes, it is very deadly. In general, Titan's terrain is relatively flat, with variations in elevation not exceeding 2,200 yards. However, local elevation differences, as shown by radar data and stereo images, can be quite significant. Steep slopes on titanium are not uncommon. This is the result of intense erosion with the participation of wind and liquid. There are several objects similar to impact craters filled, presumably with hydrocarbons. Many craters can be buried under sediment or were quickly piled up by intense wind erosion. Titan's surface in temperate latitudes is less contrasting. Many features of Titan's surface can be explained by both the action of the liquid and the consequence of cryovolcanism. The volcanic dome of Gainshaw detected by radar very much resembles the shield volcanoes of Venus. Titan has huge dunes. There is a dark area, similar to Xanadu in size, encircling the satellite along the equator, which at first is infected like methane seas. However, radar studies have shown that the dark equatorial regions are almost universally covered with long, parallel rows of dunes, stretched in the direction of the prevailing winds from west to east for hundreds of miles, like the scratches of a giant space cat. The dark color of the lowlands is due to the accumulation of carbon dust particles falling from the upper layers of the atmosphere, washed away by methane rains from the hills and carried in the equatorial regions by winds. Dust can be mixed with icy Titanic sand. According to new data, the composition of liquids in the lakes is as follows: ethane 75%, propane 7%, methane 7%. In addition, the lake contains 2 to 3% hydrogen cyanide and about 1% butene, butane and acetylene. Other reports indicate that the main components are ethane and methane. In any case, you need a swimsuit made by Elon Musk. The reserves of hydrocarbons in the lakes are several times higher than the total reserves of oil and gas on Earth. The researchers suggested that, under certain conditions, floating ice flows could form on the surface of titanium lakes. Such ice must be more than 5% saturated with gas in order to remain on the surface of the lake, and not sink to the bottom. Most of the lakes are found in the northern polar region, while in the southern they are almost absent. This may be due to seasonal changes. Each of the 4 seasons on Titan lasts about 7 Earth years. And during this time, methane can dry out in reservoirs of one hemisphere and be carried by winds to another. This is an ongoing process that does not occur anywhere else. Titanium has clear signs of volcanic activity. However, despite the similarity of the shape and properties of volcanoes, it is not silicate volcanoes like on Earth or Mars and Venus that act on the satellite, but the so-called cryovolcanoes, which are most likely erupted by an introductory ammonia mixture and an admixture of hydrocarbons. On Titan, like on Earth, storms form from time to time. The heating of the surface by the sun's rays creates upward currents in the atmosphere, causing powerful convection, movement of moisture and condensation of clouds. And unlike Earth on Titan, powerful clouds are much more displaced in latitude, while on Earth they move to the north or south slightly. And of course, one cannot fail to mention the disappearing islands on Titan. The largest of them is the Kraken Sea, slightly larger than the Caspian Sea, Liga, 3 times larger than Biklenpunga. Their depth is several hundred yards. Exploration of the Ligeia Sea revealed an unusual feature. On some radar images, light objects similar to islands appear and disappear, while there are no significant waves in reservoirs. There are 3 versions of what they might be. First, the Titanians live there, and from time to time they surface to see if all is well. Second, these deformations can be gas bubbles. And the third version is solid, floating formations, possibly ice. It took a little time and now we know the answer. It turned out that on the surface the mixture exists in the form of one phase, but at depths from 142 to 186 yards, its state changes. The ternary mixture is converted into a combination of 2 liquid phases and 1 gaseous phase. The solubility of nitrogen in ethane is much lower than in methane. It is emitted as a gas. Chemists estimate an average bubble diameter of almost 2 inches is enough for the bubble islands to be visible to radars. At the same time, the researchers note that there is not enough data to give an accurate description of the processes in the seas of Titan. For example, the temperature of the seas and their exact composition are unknown. More accurate data can provide a future mission to the satellite, which by the way is scheduled for 2026. That's when the Dragonfly mission starts. It is assumed that already in 2034, Titan will be landed in an rotary drone, which will receive electricity using a thermoelectric generator. The device will be equipped with 2 mass spectrometers, several cameras and a block of meteorological and geophysical sensors. The main scientific tasks for the apparatus will be the study of the chemical composition of samples of the atmosphere and the surface layer of the soil, in order to understand the processor, including monitoring the weather and obtaining atmospheric profiles, aerial photography and photographing of the titanium surface, as well as seismic studies. Yes, this mechanical dragonfly has amazing abilities. It remains only to hold out until 2034, and then to become eyewitnesses of these new discoveries will be a truly exciting and amazing time.